All right, here we go with page 4. We need to name all real solutions for each system. The solution to the system is where the two graphs cross. So when I look here, I have a solution at -1, -3, and +1, -3. For our linear system, there's only one solution where the two lines cross, and that's at over +2 up 4. If I have two graphs that do not cross, there is no solution to the system. All right, so for 15, it says to graph each system of equations and determine the solutions. Because there's an x squared and a y squared, that's a circle. So my radius is going to be equal to the square root of the constant, which is 5. Because there is no shift in the x or the y, my center of the circle is at 0, 0, my origin. I can count up 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, left 1, 2, 3, 4, 5, right 1, 2, 3, 4, 5. When I go to draw my circle, I want to make sure that I'm as rounded as possible, even though I recognize it's very hard to draw a circle, so we might end up putting this on the graphing calculator, or even Desmos would be better to use for graphing circles. When I go to graph my linear equation, I'm going to solve for y. X minus 1 is equal to y. I have a y-intercept of -1 and a slope of +1, which gives me a line that intersects the circle at 2 points. Again, because I can't trust my circle drawing ability, I'm going to have to go ahead and use the graphing calculator to enter in my equations. X minus 1 is an easy graph to do. For my circle, I'm going to have to solve for y. Y squared is equal to -x squared plus 25. Take the square root of each side. Y is equal to plus or minus the square root of -x squared plus 25. Remember that plus or minus means that there's two equations to enter into the calculator. So I'll go ahead and do the +1 first. The square root of the opposite of x squared plus 25. And then I'll do the negative of the square root of the opposite of x squared plus 25. When I go to graph them, I can see my linear equation. There's the top half of my circle, and there's the bottom half of my circle. When I want to do my intersection, second calc, choice 5 is intersect. Mr. Blinky's on the first curve, and I'll tell him, yes, that's right. He jumps to the second. I say, yes, that's right. And he tells me that intersection is at an x value of 4 and a y value of 3. When I go to do my second intersection, I need to take the cursor down to the other part of the graph. And when I press enter, he jumps to the first curve, and I need to press the down arrow to have him go to the bottom part of that circle. When I press enter, my intersection of -3, 4 is going to be at that point. All right. Our next graph, I have a linear equation, a y-intercept of 3, and a slope of 1. That's quick and easy to draw. And I have a quadratic. My quadratic is in standard form, So my x is going to be equal to negative b over 2a. My x is going to be equal to the opposite of negative 2 over 2 times 1. So my x is going to be equal to 1. That means that my line of symmetry is at the vertical line. X is equal to 1. And my vertex is somewhere on that line. I'm going to go to y equals, clear out my circle graphs, and enter in the quadratic. X squared minus 2x minus 1. That's going to give me, there's my parabola. I'm going to go to the table of values, and I'm going to go ahead and figure out what my vertex is because I have an input of 1 and I can center it right there. Negative 2 is my vertex coordinate, and then I have negative 1 and then positive 2, and that's going to be one of my intersections I can see because it hits the linear graph. I can go back to my y equals and I can type in x plus 3. When I go to my table of values, I can go ahead and see that there's one of the intersections at negative 1 because I have the same output there. And when I look here, my other intersection is at 4 and 7. So my two intersections are over negative 1 and up 2. And over 4 up 7. Alright, so these last two problems on this page, it says determine if 3, 5 is a solution to the following systems of equations. All that we need to do for this is to put my y value in, my x value in, and see if I get a true number sentence for each equation. 5 is equal to 0 squared plus 5. Yep, that works for the first equation. For the second equation, I'll put in 3 for x and 5 for y. I get 0 plus 0 is equal to 9. That's not true, therefore, no, it is not a solution. It must work for both. If it works for one, that's not enough. In order to be a solution to the system, it has to work for both. All right, let's see. This first equation is 5 equal to the opposite of 3 squared plus 6 times 3 minus 4. Is 5 equal to negative 9 plus 18 minus 4? Is 5 equal to 9 minus 4? Yes, it is. So it works for my first equation. For my second equation, I have 3 minus 2 squared plus 5 minus 5 squared is equal to 1. 3 minus 2 is 1. 5 minus 5 is 0. Is 1 equal to 1? Yes. Therefore, yes, it is a solution. All right, good job.